Kia ora, Year 12. This video is a new one I'm doing for the Level 2 Calculus paper back in 2014. Sounding really strange because the usual screencasting thing that I use is not working. The website's down, so I'm trying a different version. So it's going to be a little bit weird. But what the question is about is the one where we've got to find the equation of the curve. And this is the question here. Right, so we're given the gradient of a function, and then we have to figure out the equation of the graph. Okay, so what we've got is dy by dx. We need to work backwards and get y equals blah, blah, blah. And we're told that at the maximum turning point of the graph, y is equal to -4. And we have to find the equation of the curve. So there are a few ways to approach this, but the first is probably to anti-differentiate and say that y will equal the antiderivative of this. So working this back gives me 9/2 x squared minus x cubed plus c. So this is what we call a negative cubic. And that's very useful information because I can now sketch the shape of the graph. It's going to go like this. The next thing we're going to do is to use the information that the maximum turning point has got a y value of -4. So at a maximum turning point, dy by dx equals 0. And the other thing we'll use is that the second derivative is going to be negative. So our next step is to take our derivative and figure out where it's equal to 0. So that's 9x minus 3x squared equals 0. Factorising gives me 3x into 3 minus x, which gives me 2x values. So what we have to think about now is which one is the minimum and which one's the maximum. So let's substitute, let's find the second derivative, f dash dash of x, or we could write it as d squared y by dx squared, and that's equal to 9 minus 6x. Now, evaluating that at each of my two turning points, I see that at 0, the second derivative is positive, so that's going to give me the minimum. And at x equals 3, the second derivative is equal to 9 minus 18, which is -9, and that's going to be our maximum. So we have to show that in this question. The other way we could have done it is to go back to our function for y, which we had up here, and to say, based on the shape of that graph, we know that the second point is going to be the maximum. I'm not going to write all that out here, but that's what you'd need to say. You'd have to draw that graph and say, look on here, this first one is x equals 0 and the second one is x equals 3. So the point that we're interested in is the one where x is equal to 3. So now we know that 3, -4 is on the curve. And we know that the curve is equal to 9/2 x squared minus x cubed plus c. So substituting in, we get -4 is equal to 9/2 times 3 squared minus 3 cubed plus c. -4 equals 9/2 times 9 minus 27 plus c. So when we finish mucking around with that, we get c equals -4 minus 81 on 2 plus 27. And that all comes out to be -35/2. So finally, we put it all in together and we get our equation for the curve, which is 9/2 x squared minus x cubed minus 35 on 2. Or if you really like decimals, which I know some of you do, you could write it like this. Remember, never write decimals when you've got a recurring fraction, but it's okay here because it's not an approximation. So there you go. I'm not too happy with the quality of this video, obviously, because you've got all of the stuff over on the side here. So I might redo this one later, but that'll do for now. Please email me or leave me a comment letting me know if there are any questions in old exams that you're really stuck on.